really happens when a battery is overcharged. Welcome to the ecoworthy safety lab. A lot of people worry about this. If a device keeps charging for too long, could the battery overheat, swell smoke, or even lead to a more serious failure? Our company's batteries basically come with 3 safety lines of defense. First line, BMS monitoring. Second line, secondary hardware protection. Third line, battery cell protection. Today we will use 3 real overcharge tests to verify these 3 lines of defense one by one to see whether your battery can remain safe and controllable after overcharging. This test is conducted by professionals in a controlled environment. As you can see, the battery is currently operating normally. Next, we will use a DC power supply to continuously raise the charging voltage, simulating an overcharging scenario. The BMS will immediately cut off the charging circuit. What you are seeing now is the protective action it executes instantly. Now let's look at the live data. You can see the input voltage briefly spike when it reaches the protection threshold, then quickly drop back down. This indicates that the charging circuit was disconnected in time. So once the voltage falls back into the recovery range, the battery can resume normal charging and continue operating normally. BMS protection test passed. But what if the BMS fails? Is there another layer of protection? The answer is yes, secondary hardware protection. However, not all models come with this feature as standard, only some batteries include it. Some models use a circuit breaker for this protection. This is the Cubix 100, equipped with circuit breaker protection. Next, let's see how it performs under overcharge conditions. Let's go back to the laboratory again. You can see that our battery is currently in a normal condition.
To simulate an extreme failure, we intentionally damaged the BMS MOSFETs, preventing the BMS from disconnecting the charging circuit. We then continued charging the battery to verify the secondary hardware protection. As the current continued to flow, the circuit breaker tripped, disconnecting the battery from the external circuit. Keep in mind, the circuit breaker doesn't protect against overcharging, it protects against short circuits and overcurrent. Overcharge protection is handled by the BMS. This test simply shows that if the BMS fails, the secondary hardware protection can still isolate the battery.
For our final test, we will conduct an overcharge test on the battery cells, the ultimate safety safeguard.
Because the enclosed test setup is difficult to film clearly, we move this comparison to a position where the process is easier to observe. As you can see, before the test begins, the battery cell is operating under normal conditions. Next, we'll increase the charging voltage to 5.5 V and begin the overcharge test. Under an extreme overcharge test at 5.5 V, the eco-worthy cell showed only slight swelling, with no fire, explosion, or thermal runaway. Although the cell sustained irreversible damage, its overall condition remained under control. From intelligent BMS monitoring and early intervention, to hardware-level circuit breaker protection, and finally the cell's built-in pressure relief mechanism as the last line of defense, ecoworthy has built a comprehensive 3-layer overcharge protection system. Safety isn't a matter of perception, it's proven through real-world testing, backed by verifiable technology, and reinforced through multiple layers of product design.
Although our batteries have multiple layers of protection, in daily use, disconnecting the power promptly after the device is fully charged can further ensure safety and also help extend battery life. If you'd like to see more real battery safety tests, follow us for more, and let us know in the comments what you want us to test next.